Hello, and welcome to Thematic Intelligence Podcast, a global data thematic intelligence we track over 100 tech, industry, ESG, and macro themes impacting all major sectors. I'm Martina Raveni, and today I'm joined by Jose Acain, CTO and co-founder of AstroForge, an asteroid mining company. Hi, Jose. Welcome to Thematic Intelligence. How are you?
Good. How are you doing? Thanks for having me on.
Thanks so much for being here. And I would like to start by asking you if you could tell us what AstroForge does, how it started, and what's its mission.
Yeah, I think you explained it pretty concisely there. We're going after asteroid mining in a nutshell. What AstroForge is doing is providing off-planet resources for the benefit of humanity. And more specifically, we're going after near-Earth asteroids, so asteroids much closer than the asteroid belt. So a 2-year round trip to extract platinum group metals and return them to Earth for sale.
That's really interesting. And yeah, I can see that the future of mining is rapidly evolving. New frontiers are opening, and in this case, extraterrestrial resource exploration is definitely one of these. So to me, it's not science fiction anymore. But my question is how this is actually possible, and I mean, how do you choose which asteroid to target, or what about the quality of the material? How confident are you that the asteroids will contain what you're looking for?
Yeah, I'll start with the first question of how is this possible? I think a lot of things are possible if you throw enough money at it, right? So to me, I think asteroid mining could have been done decades ago, if we focused purely on that. But in the last 10, 15 years, a significant change in the access to space and the low-cost access to space in particular has changed dramatically. So for us, we viewed that as a flag post to really anchor our business model, right? So I guess to give you some examples, so about 10 to 15 years ago, a cost of our mission just to get out to space would cost $400 million. And for us, it costs less than $10 million to get out there, which is significant orders of magnitude difference from what it used to be. So a startup can go out and actually start this thing and take a little bit more risk and iterate on the design. So that was a
Yeah.
major turning point. Your second question was how do you select your asteroids? Is that what the
Yeah, exactly.
yeah
And
yeah
further than selecting asteroids, how are you sure that will contain where we're
yeah
looking?
the asteroid we have asteroid evidence here on Earth, right, in the form of meteorites. So we've done significant studies on the meteorite database. We partnered with the Colorado School of Mines, for example, and we studied the composition of the asteroids that have hit Earth in the meteorites, and we realized that we have to go after the metallic types, and the metallic types contain up to 16,000 times higher platinum group metal concentrations than found here on Earth. You can map the meteorites to specific asteroid types, and like I said before, the metallic types is really what we're going to go after.
And you said that you use basically light reflection to see metallic and non-metallic. And can you define also which type of metals contains? Do you have that degree of accuracy?
We don't have that degree of accuracy on the ground, but we do. So we
Okay.
do have to have discovery and prospecting missions prior to us doing the refining and mining, in order to ensure that the concentrations that we expect, that we estimated on the ground, are what we are actually going to go out and mine.
Okay, I got it. And my next question is mainly came from about the recent NASA mission that collected 70.3 grams of rocks and data from the Bennu asteroid. I don't know if you
Amazing.
know that, and returned to the heart last September 2023. So we had the Bennu samples that proves in a way that this is durable, and at least to me definitely spread some optimism around asteroid mining. So it's something that can be achievable, but it's really a small amount of material. So how can the amount of material collected be scaled? So what kind of infrastructure do you think we need to upscale space mining?
Yeah, so the OSIRIS-REx mission that you referenced, they went to the asteroid Bennu. That was primarily a science mission. So there was a lot of instrumentation on board, and it was not purely focused on optimizing for the business case. For us, we don't carry the scientific instruments. We don't carry excess mass. So we're able to go out there and secure larger amounts of material to bring back. So really the spacecraft and the entire mission is designed around getting to the asteroid, bringing back valuable material, and maximizing the amount of material returned. As far as infrastructure, what we're doing now is creating is creating I would say a dirt road, right? It's not a highway, it's not a freeway, it's not a streamlined approach. There's a lot of things that would make this easier if there was infrastructure in place. But I think what we're doing is providing the all-in-one solution where you go out, mine the asteroid, and come back. And again, that's nice, that's great, but there's definitely ways to optimize this. You can consider, like, I think there's burgeoning industries in aerospace where you refuel in space. You have tugs that'll take you out there, where you dock with them in low Earth orbit, and then the tugs will take you out, etc. But that infrastructure is not in place now. But I think for us, we're not reliant on that in order to achieve our mission.
Okay, I'm thinking now in terms of challenges, because we are talking about space mining. So what are the main challenges, technical and known, of mining in space?
Yeah, I mean, space, as you know, and I'm
Apart
sure
from the cost.
apart from the what? The cost? Yeah, I mean, cost is, yeah. Man, that was my first thing I was gonna say. No. I mean, as well as everyone, that the space environment is a very extreme environment. So the technical challenges arise because you have to design for those extreme environments, the vacuum of space, extreme temperatures of cold and hot. And then on top of that, you have the radiation effects that affect the electronics of the spacecraft. So all those things you have to take into account when designing, and things that we don't necessarily think about here on Earth increase the difficulty of doing that in space. The other challenges I would highlight here is the asteroid itself, like the asteroid data. We have, like I said, we have the meteorite database, we have ground observations, but there's very little truth data about asteroids, right? Like, there's a handful of missions that have gone there, returned samples. That's great, but there's tens of millions, hundreds of millions, billions of these objects out there. Only sampled a few of them. So getting the actual truth data, I think, is something that we need more of, and we need to identify in order to really anchor, making sure that the targets that we're going after is really the ones that we want to go after. It's similar to, like, the terrestrial mining space, right? You have to go out, sample these things, say, like, okay, this actually makes sense. So actually there is gold here, or there is nickel here, or
Yeah, that's very true. That's very true. And one of my last question is probably you would be asked a lot of time, but what about the timeline to make asteroid mining possible? Because I'm thinking, apart from all the technical challenges, if also in terms of how far is the asteroid from us, also in terms because it needs to go there and collect samples and come back. So it will take literally years, if not decades. So yeah, what about the timeline, Jose?
Yeah, I think it touched on it a little bit earlier. So we're not going to the asteroid belt. So the asteroid belt is I think what a majority of the people imagine when they talk about asteroid mining. And the asteroid belts take 7 years to get there one way. For a business that doesn't quite close
It's not feasible.
business
Yeah,
case at all, it's not feasible at all. But for us, we're targeting things in order of a 2-year round trip. So really, 6 to 9 months to get out to the asteroid, a few months to do some refining, and then 9 months to a year to get back. So in total, 2 years round trip. So based on our milestone, like, if everything was perfect in all of our missions that we have planned, we aim to bring back samples or payload, return material that we can sell by the end of the decade.
I see. And if we take a leap in the future and asteroid mining resources would flood the market, so do you think there would be a rapid devaluation of the global raw material, or do you think that since it takes time, everything will adjust smoothly through time?
Yeah, I mean, we're not bringing back, the annual market cap of platinum, for example, is $60 billion. Our missions don't return in the order of billions, right? And per mission, we're going to aim to return definitely less than, like, 5% of, like, the total annual market cap. So to us, we've had people on our cap table that are in as spot traders, commodity traders, and they've done some analysis for us. We don't expect to crash the markets or devalue the markets. On the flip side of this, though, to me, making these very rare material accessible opens up potential possibilities for new technology. So I think in either case, it's a win, right?
Yeah. Thank you very much, Jose, for joining us. It's really been a pleasure. Thanks all for listening, and from us in Thematic Intelligence, see you next time.